that Quantumwise tool, we are having a different computation techniques. That means, suppose we have designed some structure and we are giving some boundary condition, because to simulate anything, we have to give a particular boundary, or you can say mesh, so that on that particular boundary structure, whatever the structure we have particular surrounding boundary, that will be computed, and it will extract the parameter from that particular structure by using a different technique of different methodology. Okay, like in the quantum wise, we are having this four kind of like density function theory that we already studied in signal processing and mathematics. Then semi empirical tight binding method, that will be when you are having a two atoms, and if you want to find out the energy of the atom, then we are using semi empirical tight binding. Classical potential methods, non-equilibrium green function, these are all the methods that is used in several mathematical operation. Okay, that means if you are having any structure, that structure firstly converted into mathematical function, and then it will be executed using this simulation tool. Okay, so we'll see how we can go for this mathematical approaches. So first, when you double click the software, uh, any shortcut icon that is available in your desktop, you just double click it, and once you double click it, you will see this pop-up window. Okay, in that window, it will ask two things: example project. Okay, that will be by default, because this Quantumwise tool is having several examples. Okay, pre-built examples to learn the newcomers. Okay, and we can also create one more destination where we can save our structure. Okay, that also we can do. Okay, so if you want to create a new, you can go with this create new option, and it will ask you at what particular location you want to create the folder with the project name. Okay, two things: one is the name of the folder, and the second is the location. Clear? So you simply click create new if you want to create a new thing. Suppose you want to execute already existing, uh, you can say a project, that you can open it with the help of this one. Just click the example project and click open. Okay, once you do that, this window will come out. Okay, this is the main, you can say GUI. Okay, graphical user interface, main pop-up window. In that, you have to learn each and every tools, you can say. So the first tool is builder. Okay, so what is the use of this builder tool? You can design any kind of structure with the help of this builder tool. Okay, now the second is scripter. Now this scripter tool, suppose you are a computer science person. Okay, and you have a very good command in the Python, and you want to script your own language, own program, that you can do with the help of this scripter. Okay, that scripter is used for that. And even though you can edit or customize your scripter with the help of this custom and editor. Right, now suppose your structure is designed either with the script or either with the builder. Builder means more, it is more easy to understand for this EC person, or for any person to understand the structure, and they can directly put the structure instead of writing the code for particular atom. Okay, so in this tutorial, we'll basically see the structure only. We are not going for the scripting. Okay, so now once the structure is completed, you have to put it into execution portion, that is the jobs. Okay, this is the one more tool that is used to execute the designed structure. Okay, now once you have put it your structure into the simulation, okay, that is the jobs, then after finishing this execution, you can have several files that will be useful to see the outcome, and that will be done with the help of viewer. Okay, viewer is used to see the outcome. Okay, now this is the database. This database is very much useful while selecting a different kind of alloy, atoms, molecules, and other things. Okay, so that means suppose I want hydrogen atom. So where you will find? So you can find out inside this database. You want FeCl3, so you can find out here. Okay, so this is the database where you can grab a different kind of atoms, molecules, alloy, and other elements that you can grab it. Clear? So now this GUI is divided into four parts. First is your the tools. The second portion is your project file. Means suppose I have created my project file name as a Vijay Lab 1. So it whatever the things is inside that Vijay Lab 1, that will be put it here. All files will you can access from here, from the project files. Okay, now once you have executed, suppose this is my build first example, benzene. Okay, so benzene is having .hdf5, that means it is already executed. So what is my script file? My script file is .py. Always remember two things: script file or designed file is always with the format .py, that is Python file. Okay, and once your simulation is done, additional file will be generated in the format of .hdf5. Clear? Only, and you can observe the output while selecting while check marking this .hdf5 file. Okay, once you check mark this one, the content or the parameter, measured parameter, will be listed on the left floor. This is the third of tab, which is called lab floor, in which you can see the outcome. Okay, now the fourth one. In the fourth one, suppose I have selected the density of state. Okay, so once you click density of state, this density of state will be in the black color, otherwise it will be light shaded. Light shaded means it is not active right now. Okay, so based on the outcome, this will automatically turn on or turned off. Suppose in this one I have band structure. So once I will click the SDF5 file of the band structure, this light color of this band structure analyzer will be turned on. Right now it is turned off. Once you click the band structure, it will turn on, and once you click it, it will directly show you the output. Clear? Why some of them is in light color and why some of them in a dark color? Okay, because this one is now turned on and this one is now turned off. Okay, and this is your menu bar. The same thing will be listed here only. Now in the menu you will see these are the things. First, in the file you will have an option to go out of this tool. Okay, and you can import your files from the example files if you want, or some other location that you already saved. Now project, in the project you can create the new one here also. Okay, suppose I have created one project that is complete. Now I want to create again, so you can directly go into the project and select the new one. Okay, and you can design again. Now view, that will be just viewing how you can, how the appearance, how you would like, whether you want a full screen, whether you want half screen. Now tools, these tools I already explained here. These are the same thing is given here also. Okay, that is inside this tools option. Then window is something the same thing, that where you want. And then helps, in this help you will have several tutorials in the Quantumwise website. Okay, in that particular website you can see a bunch of tutorial individually they have given with pictorial form. Okay, suppose if any newcomers will come and want to learn this software, they can go into the tutorial individually and they can follow particular tutorial and they can do the simulation in this particular software and they can design it. Okay, now apart from that they are having some other option also. Add-on manager means suppose if some new updates are coming here in this particular software and some add-ons are not embedded here. Okay, some plugins you can say. Okay, so those plugins you can update from this one, and you can add from here also. So these are basically adding some extra peripherals, or you can say extra script files that can be related to this Quantumwise tool, that you can update from here. And licensing, you don't worry about this one. Okay, so we have a license software. So this one is already done. Now we'll see one by one what the this vertical toolbars. Okay, so the first one is your builder. Okay, once you click on the builder, it will show a create atomistic structure. Okay, then once you create your design, you have to set up a calculation. Means once you design a structure, suppose I have designed p-n diode. Now in that particular p-n diode, what are the parameters we require to simulate those particular p-n diodes, so that it will work as we have seen in the realistic nature. Okay, then once we have put it all the calculation, then after we can put those structure into simulating uh, run job, so that it can run the simulation structure. Then after simulating the structure, you will find the result that we have to analyze. So these four things you have to always remember. Okay, and this you can do with this builder. Once you click the builder, you will see this one. Okay, we'll go in more detail now. See here, once you click the builder, this is the things: build structure, setup script means some calculation, and then run it. Okay, and now once you put in into the job, this is the option to put into the job. There will be asked two things: whether you want to simulate those particular, because this is a quantum level software na, so it will require a huge computation efficiency computation process. Okay, so either once you decided to simulate those particular structure in your particular system, you cannot uh, you you cannot work for other things, because it will take 99% of CPU utilization will be done with this software only. Okay, so you cannot access other, like if you want to access some browser, it will be very difficult, or it will take a lot of lag. Or remote cluster, suppose you have some server in your college, and you want to simulate on that particular server, so that you can access your system. Okay, now once you click this builder, this window will come out. Okay, in that window you have several options here. Okay, favorite, builders, bulk tools, coordinate tools, device tools, graphics, and some other things. This is very essential things for designing this structure. Okay, so once you click on the builder, this window will come out, and once this builder window will come out, you can have access to many things. So this one is called stats. Okay, in this stats, whatever the structure you have designed, it will come here only. Okay, in the pictorial form, not in the text form. In the pictorial form, it will come here. Okay, and now once you click, suppose I will click this one, first one, so whatever the content it's having, it will show you here, and then you can modify with the help of these tools, or you can say it as a modifier tool. Okay, and the respective code you can see it here also, and you can give the command also with this option, but we are not going for these things, so we will only go for these things. Okay, so suppose my design is completed, so suppose this is my design, so how we can activate this for job? This is the option, arrow option, you can see. Once you click it, it will have a bunch of options. Okay, I will show you in the live demonstration also, don't worry. Now, so you can individually select it by with the help of this mouse. Okay, and you can identify which structure is now active by seeing this rectangular circle. You can identify this structure is now currently active, and these are now inactive. Okay, so you can make individual to active by right clicking it. Now script generator. So in this script generator, suppose I have designed this structure. Okay. Now I want to simulate this one. So you just simply go into this one and send button, and then here it will ask what kind of analysis you want. Okay. So in that, different kind of analysis we are having and different calculator we are having. Once you click the calculator, it will ask you what kind of analysis you want. So in this analysis you will see whether you want mobility, whether you want band structure, density of state. These things you can drag it from here and you can put it here. And then the name of the file, this is the result file that will have a format of .sdf5. Okay, once you click it here, it will send this structure with this computational parameters into the job. Okay, and then once you send it, it will show you with this you can say this rectangular box. Okay, with orange color, and the name with the .py. And then you have to click this one, and then you have to start running. You have to play with this one. You have to click this one, then only it will run, otherwise it will show you the pending. Okay, so even though to put the structure into the job, your task is not done. You have to click that particular file and you have to make it start in manually. Okay, and then once this project will be finished, it will be come in your lab floor. Okay, so you have to check the lab floor. So how to analyze the results? So suppose I have created this one GA100.sd5. So once you check mark this one, it will come here. Now once you expand this one, so you can see that gallium arsenide with 100, you can see that you are having three things. One is band structure, electron density. So which one you want to see first? Whether you want a band structure to see or whether you want electron density to see. Okay, so once I will click this one, you have options to click here, or if you click the band structure, the band structure will come out and you can click those things and it will show you the output. Okay, so now for the density, electron density, these are things we have to do. Now we'll see how we are going to design silicon carbide crystal and we can analyze the band structure. Okay, now I am going to tell you how we can design and simulate it from the starting. So once you have to create new. Okay, once you create new, you have to give the names. Now click on the builder. Okay, once you click the builder, here you will see plus sign. In that plus sign, once you click this plus sign, it will give you 5 options. Okay, in that option you have to choose from database, because SIC we have to choose from the database. Okay, that is a plugin. So once you click the from database, it will direct you to this database. So you can see that this is the database. So in that search option, you can search any element, but for this project we required SiC, silicon carbide. Okay, so we'll write directly here SiC. So you can see it here, SiC. Okay, so how to add this one in our workspace? So either you double click it or either select it, and here it is the plus sign. You click the plus sign. Okay, once you do that, this one plus sign, this structure, okay, this one, once you click it, this structure will be come in your workspace. You can see it here. Okay, so now once this structure is placed here, you have to send this one into the script, means you have to put some calculation. So I will click on this arrow and then we'll see this window, script generator. Okay, in that script generator you have to first select any calculator. One calculator you have to select, and the type of analysis what you want. Suppose in the analysis I want band structure and electron density. I will click both and it will show, save it as a my project /sic.sdf5. Okay, and then after again click on this arrow and send it into the job. Okay, so the calculator which we have given here, new calculator, it's having a four different type of calculation, like LCAO calculator, okay, plane wave calculator, semi empirical calculator, force field calculator. Okay, out of that you have to select one, okay, based on your structure and analysis that you have to learn from the physics point of view. Okay, so first, for the band structure analysis, and for band structure analysis you always select Lakao calculator, okay, because it will give the in-depth energy of the particular atom. Now for this you have to choose the basic parameter, and this basic parameter means Ka, Kb and Kc. These are the lattice value, K point value. That means at what particular axis your points will vary, means more the value, more accurate you will see. So we have to select the density. Okay, so the density of this sampling point will be 2 2 2 has been chosen by default. And now in that one you have to choose the density mesh cutoff. Density mesh cutoff means, suppose I'm having a particular structure. In that particular structure, how many grid lines you are putting, means more dense means more accurate value you will see, okay, or lesser dense means less accurate value you will see. So you have to check mark this print result summary to log, and then you have to press OK. Clear? Now for the band structure, this one is the basic calculator. Now we have band structure and energy density. In that also you can modify, or either you can put it by default. So if you want to know, if you want to define your particular band structure diagram, you can go double click it and you can define it here. So points per segment, you can give 100 or 200 or more. So more the points, more computation time it will take, and more accurate it will give the result. So lesser the point, less computation time it will take, and it will have a less accurate result. So now band available means Fermi level band. So I will include always all type of bands it will see, whether direct or indirect. Now brilliant zone, so that you have to understand from the physics point of view, what is my brilliant zone. Brilliant zone is nothing but, if you select a one unit cell, in that particular unit cell, what are my banding values will be considered for this particular zones. So we are having first brilliant zone, we are having second brilliant zone, okay, and this point we can select from the option. I will show you how we can select this brilliant zone value. So this is the, they have put it all the brilliant zone value, okay, but we'll select particular, will not go for all. So once this parameter is fitted, we'll go for the calculation, okay, run calculation. So once you put those structure into the simulation, it will come it here SIC, and then you have to click on this execution button. Okay, once the execution button will be clicked, this will go into the simulation process, and you have to wait for the result. Okay, so how you will identify whether my simulation is done? So that will, you can identify with this check mark. You can see it here. This one is rectangular box. Once it is finished, it will come like right tick. Okay, once it is converted into the right tick, that means the simulation is completely done, and the result will be shown in the left floor. Okay, so you can see that once the result is completed, you again come into the main GUI, and here you click check mark all. Okay, and once you check mark this sic.hdf5, you will see it here in the left floor, and you have to expand this SIC. Okay, once you expand, it will show you these three things. First is the structure, second is the analysis, and this one is also analysis. So second one is your band structure analysis. So once I will click the band structure, it will show you this band structure analysis will turn on. You simply click this, you simply click once band structure analysis while selecting this one, and it will show you the band structure of this one. See, this structure will be shown here. Okay, and you zoom particular this area, you will see it like this one. So it will show you two things. One is direct band gap value. Here it will show you, and second is indirect band gap. So what is the difference between the direct band gap and indirect band gap? Have you heard about the band gap? I think you already learned in 12th physics and maybe in the BTech first year. Do you know band gap?
This is the difference between conduction band and valence band.
And the valence band. Okay. So have you heard about the direct band gap and indirect band gap?
Mm,
Maybe this one is new for you, right?
yes.
Okay. So how to find out the direct band gap? When the for the I will say this is your valence band, okay, and this is your conduction band, right? And this zero is your Fermi energy level, okay. So below this Fermi energy level, what what is your maximum peak? Suppose this is my maximum peak, okay, that reaching toward the zero, clear? And on the same point here, if we are having any band and if we are taking the value between this straight forward vertically, that means this is the direct band gap. Now the indirect means this is my maximum peak that is coming toward the zero, and this is my lower maximum from the conduction band point of view and coming toward the zero. And if we take the distance between these to this is called indirect band gap. Is it clear, everyone? What is direct and what is the indirect? I will show you with marker. See. So the band gap between these and this, you can say this is whether it is maximum or lower for that particular point. So this one, this is called direct band gap. The value between this point to this point. Clear? This is direct band gap. Now the value between this point to this point is called indirect band gap. Okay, right, everyone?
Yes,
Kunal?
sir.
Yes, sir.
Okay. So now we'll also see these things. Don't worry. Now the next is electron density. Okay. So you can see the electron density that more purplish will show higher dense value and lower this sky blue color is shows you a lower density. Means density means what? The electron is having how much density is there, how much mobility, how much electrons are residing on that particular area, that is showing here. So this one is just a temperature view. You can change the range of this one. This one is not useful. Okay, this is the first thing. Okay, now we'll see how we can operate the software. So this is, can you see this desktop?
Yes,
Yes,
sir.
sir.
Okay, so this is the icon for Quantumwise ATK latest version. Okay, start Quantumwise ATK R 2020. Just double click it and wait for few seconds. Okay, now this one will come synopsis Quantumwise ATK. So now you can see it here. Suppose the option, suppose if the first option not pop up that I have shown you, like that one that asks about this location and other things, this one, because I have checked unchecked mark this one, show on startup. Okay, if you uncheck this one, it won't show you these things again and again. Okay, so I have made it, so you can create it from here also. Once you click on the new, it will ask you here. Okay, so you can choose particular location and you can put the new name. So here we'll create a new. This is my design. I will show you here some of the design that I have worked on this one, so that you have some idea how we can design the things. Can you see this one?
Yes, sir.
Yes.
Okay, so you already done the interconnect, right? So
Yes,
this is
sir.
nothing but an interconnect with structural simulation. So I have done some doping. So you can see that multiple layers I have designed. 4 layers are there, and in that particular 4 layers I have placed ASF5 doping. Okay, so this structure you can design with yourself also. Okay, so uh, this is with a different doping, having a different spacing between the layers. Okay, but we'll see the basic one first. We'll create new, so we'll go with the lab 1. Okay, and in that title you can give the any name, and here you can choose the particular location where you want to save, right? And then press OK. lab 1 is already there. Okay, so lab 2 कर लेते हैं. अच्छा, choose folder is already registered as a project. Do you wish to rename the project name? No, भाई. I had to create new one. Create new folder. Lab 1 start. And in that you can select now. Okay. Now once you click it, everything will be removed from here. Now you can see it is a blank, right? It is now blank space, and here you can see a bunch of options. I will make it smaller for you so that you have better view. Now you can see that. So each option you have to explore. Okay, now this one contains the general information, okay, about your structure. This electronic property, in that electronic property you can observe what are the things you can explore for particular atoms. Okay, you can see that you can identify the band structure for the simple atoms, for the complex structure, density of state. Okay, effective band structure, local density of state. So many things you can play with the structure. Okay, apart from that, density and potential, compare. Even though you can compare, suppose I have generated silicon band gap and germanium band gap, and I want to compare, you select both the structure and compare it. Electrical property, like you can give the electrode, that yeah, mobility, you heard about this mobility. Okay, IV characteristics you can identify for the CMOS inverter if you design here. Okay, and these are the things. Okay, now we'll go for the builder this here. Now click the builder. Now this new window will come here. See here, 2 windows are here. Okay, so open it. Now here, this is your workspace. In that workspace you have to put your elements. So this is the plus sign through which you can add. So click add, and here bunch of options are there. Okay, by default plugins are also there. So I will go for from the database. So you have to click on the from database. So once you click the database, it will show you a database. See here, several elements, molecules, alloys are here. Okay, you can explore. There is a lot of things are here. Okay, but suppose I want SiC. Now this is the SiC. Click it and add it. See, can you see the structure?
Yes, sir.
Okay, so suppose in that structure, this is the by default structure, but I don't like this by default structure. I want to change the bonding energy. So what is the distance between this atom and this atom. You can select individually. So how to change the distance or how to measure the distance? This is the measure tool. See, can you see it here? Measure distance, angles. Once you click it, it will come here. Three things will come. If you want to measure the distance, you can click distance. If you want to measure the angle, you can click on the angle. Okay. So suppose I want to measure the distance. Click the distance and select two elements. This one. You have to place this scale by clicking one click. Once you put one click, it will place it here. Okay. So you can find out that the distance between these two atoms means Si and C. Okay. The distance between this one is 1.88 Angstrom, means 10 to the power minus 10. Right. Now I want to find out what is the band structure of this, whether it is a semiconductor, whether it is a metallic, whether it is an insulator. That you can identify with the help of band structure only, right? Band structure is always useful to identify the nature of the particular compound, like SiC. So I will go here, you can see it here. Click this one and you will see some options. So first I will go for the script generator. Click the script generator and it will show you these things. This is your structure that we are going to analyze, and this structure is bulk. Right now it is a bulk. We have not added any electrode to make it as a device. So if you are working with the device, you can convert this bulk structure into the device, and you can put left and right electrode, means positive negative electrodes. That I will show you. Now in that one you are having a 4 tools. Okay, so how to identify, because we don't have much inside the physics backgrounds. Okay, we have basic physics, but we are not inside, we don't have any knowledge of we don't have much knowledge about this physics. Okay, so how to identify which particular tool is more appropriate? So I will give you a shortcut method. So for that, suppose I have put this force field calculator. This is my force field calculator. Double click it, it will come it here. Now suppose I want to find out the band structure, and I will go into this analysis tool and I will place band structure. Now you can see that this band structure is not showing here. It's having a straight line. That means the tool that we have selected is not appropriate to calculate the band structure. Are you getting my point? Maya and Kunal?
Yes, sir.
Are you getting what I am going to show you? How, because we don't have much information about this Lakau calculator, plane wave calculator, semi-empirical calculator. Okay, to go the detail with this one, it will take more than 1 week. Okay, so to easily identify what we can do, we can select any one of them and then what analysis we want. Suppose I want band structure, so I will click and it will show you this thing. Now I will remove this both the things, simply delete it. Okay, now I will put semi-empirical. Okay, semi-empirical is showing correctly. Now I'll put band structure. Now you can see that with the help of semi-empirical, the band structure can be calculated, right?
Yes, sir.
So this is okay for me. Now for Lakau, and now again we'll select band structure. Now this calculator is also helpful to calculate the band structure. Okay, now I want to modify modify this calculator. So I will double click it and we can see it here. So what modification you want? So this is the by default value. If you don't have much idea about the numerical accuracy, basic parameters, you simply go with the basics by default parameters. Okay, or if you know what this DGA, exchange relation, pseudo dojo, and this unpolarized, polarized thing, you can play with it. That depends on you and your learning. Okay, but here I will show you the basic thing. Okay, so if you want a basic sets, you can see it here also. Counter, numerical accuracy. Okay, this means density match functions, iteration, algorithm, what kind of algorithm it's taking. Poisson solution means boundary condition, what kind of boundary condition it is taking, whether you want a boundary at all 4 particles, you can choose the direct boundary. Okay, so I will take FFT only. So we are doing the DFT analysis. These are the things. So I will take it as a by default. Now for the band structure, click it and make it 100. Okay, and click on this one. So it will take all the values of the band structure. So I will show you this brilliant zone. Now click OK, and it will show save the file with sic.sdf file. Okay, now again I have given all the parameter by default. Now click here and put it into the job manager. Once you click job manager, again one more window will come out. Yeah, so you can save your file in particular location, save it. Okay, here you will see the option whether you want to simulate this particular structure in particular machine, or you want different machine. So you can see the list of machines are here. Okay, so I will go with this one only. Whether you want serial execution, parallel execution, means how much processing speed you want to give that to that particular simulation. So click OK, and now you can see here. So this is my structure. So this one is already finished, previous one. So once I will click this one, you can see that a rectangular box is there. Rectangular box means it is not started yet. Okay, and in this status window you can see that the job is pending. So how to make it start? So you click it and then you have to start from here. Start selected job. Once you click it, you can see the symbol has been changed. Okay, and now it is showing the job is running. See, and you can see the log file here also. This is the log file. It is running here. You can observe that, see the progress. Okay, now it is calculating eigenvalues, density matrix values. Once everything will be computed, it will show you a right check mark here and it will show you finish. Okay, so you have to wait until the job finished. Now the DFT calculation is going on. So it is calculating the band structure value. Now I will also show you here. Now you can see that here this SDF5 file is now creating. Okay, so once everything is done, we'll show you here. So now you can see that the check mark. Okay, and now here you can see the finished, right? And if you drag at the side, you can see that how much time it has taken to finish this particular structure. 40.23 second time it has taken. Okay, so now we'll observe the output. Okay, so in the left floor right now nothing is there. So once you check mark this one, SIC SDF5, see, you can see one file is there. You expand this one and you can see this one is your structure and this one is your band structure. Okay, this is the design that you have created and this is the band structure after simulation. So once I will click this one, several options in the electronic property can be seen here. So I'm only worry about this band structure. So I will click on the band structure analysis. Once I will click, new window will generate. You can see it. Can you see it?
Yes, sir.
Yes, sir.
Okay, now this is my 0 point. Okay, so 0 point means Fermi level. You can see it here. Once you drag it here, it will show you Fermi level. So now in that band structure, you can easily identify it's having some kind of band gap, right? This one is having some band gap. So how much band we are having here. So how to measure this one? So you can see that here, this is the arrow key, and then you select this one, measure. Whether you want vertical measure, whether you want horizontal measure, that you can choose. Suppose I want vertical measure, so click on the vertical measure, okay, and then this plus sign, you can see 3 plus sign, you can move this one to particular location. Suppose this location point I want, okay. See, this is how much direct band gap is, how much 4.54. So I will make it more accurate if this is the point. So this is 4.56. If I will make it more accurate, it will come 4.56. Okay. Again, we can measure this one. Now this value is 4.55. So this is the direct band gap, the lowest one, because this one is how much 4.56, and we have to find out the lowest band gap. So this is the lowest one, direct band gap. This is called direct band gap. Okay. And for indirect band gap, this is my maximum peak. So here we can find out measure. Okay. So I will find out here this one and this one 1.36, right? You can see here indirect band gap is 1.356 approx, and this is the indirect band gap. Clear how to identify this band gap, direct band gap and indirect band gap, right?
Yes, sir.
Okay, so this is the points that we have measured here. Gamma, X, W, L, gamma, K. This one is repeating again and again. Okay. Now I will show you the Brilliant zone. What is the Brilliant zone? See here. For this particular element, you can see it here, Brilliant zone viewer. Can you see it?
Yes,
In
sir.
the builder, once you click this Brilliant zone viewer, you can see the what is my Brilliant zone value. So based on this Brilliant zone value, you can put the particular value for this band structure. Okay, you can see it here. So what are my Brilliant zone values are here? Gamma, this is my center one is the gamma. If you see it here, can you see it? This
Yes.
center atom, we are having different atoms, okay, in that particular Brilliant zone. So this one is the gamma value, L value, U value, X, W and K. Now I want the band structure only for gamma, W, K. That also you can find, or otherwise you can find out the band structure for gamma, X and U and gamma. Clear? So it depends on you at what particular Brilliant zone value you want to find out the band structure. Now this is the semiconductor property that I have shown. Now I will show you the metallic property. Okay. Now I'm deleting it. Now I will create one more here. Nano ribbon. Now I will show you pure metallic preview. So this is a carbon atom. 4 carbon atoms are here. Okay, this is a 4 carbon atoms, right? Now suppose I want a carbon atom of 10 Armstrong, means I want to extend this one at C axis. So how to extend this one? Now I will tell you how to play with this structure. Now you can see it here. Repeat. Okay, if I will repeat at A axis means you can see it here. This is my A axis. Okay, this is my B axis and this is my C axis. If I will extend to A axis, it will give a number of layer will increase, right? So we'll see it here. Suppose I want to extend this structure to A axis with 2, apply it. Now you can see at the A axis you are having now 2 structure. Can you see it?
Yes, sir.
Okay. Now I want to extend this, make it 1 and put it 5, 4. So it will give like a ribbon. It will be like a ribbon. You can see chain of this thing. Okay, right?
Yes, sir.
Now I want to make these things at the center of this boundary. This is nothing but a boundary. Okay. Now sometime what will happen? These atoms will go beyond this boundary. Okay. Then what you will do? And you can make it center. How to make it center? You explore these coordinate tools, and here you have center. In that center, check mark all 3, and it will put this structure center along all 3 axes. So apply it, and now you can see it is at the center. Can you see it? It is at the center around A, around B, and around C. Clear? Now suppose I want to change the spacing between these two, this and this. So how to change? Just select these atoms and grab it down and put it here. Now you can see that the distance between two is now changed, and that you can identify the exact distance. Okay, suppose if you are designing something and you want to have precise scaling, then you select the scale, click the distance and select two atoms, and you can see the distance between these two is 5.5 Armstrong. Now I want to find out what is the length of this one. So select this one and select this one, or you can select this one, 38.19. Now I want to find out the width also. Okay, so how to find out? Just select this one and this one, 5.02 Armstrong, right? Now you want to modify the band. Suppose I want to check the distance between this one is 1.42 and Armstrong, right? But I want to slightly produce the defect. I want to create a defect in the structure. So how to create? Simply click particular atom and put it slightly backside. Now I will check the defect angle. Okay, now you can see that the angle between these two is 1.61. Here to here it is 1.41, and here to here it is 1.27. But the other atom is having 1.42 exactly. Now can you see the difference? Now you can see the difference. All the bonding atom is having the exact similarity of bonding length of 1.42 Armstrong. However, when we have created a defect in the structure, we are having a different bonding energy between the two atoms. Okay, that means we can even go at the bonding level kind of thing to modify it to have a different property of the particular this structure, and we can also find out a different electronic property of the particular structure. So this is the thing. In the research, people are modifying the structure and finding what kind of impact is in the real world. Okay, so these are the things you can do. And even you can delete particular atoms and make it center, right? Now we'll simply take graphene nanoribbon of 4 atom and we'll see the band gap. Now this is still on the bulk, semi-empirical, and then analysis, band structure. Okay, now in that band structure, now you can see by default it is showing only two things. G means gamma, gamma and Z. Now you have to identify what are my brilliant zone. So to identify the brilliant zone, you have to go into your structure. You have to go into your structure and find out the brilliant zone. Okay, click on the brilliant zone and now you can see what are my brilliant zone. So brilliant zone is gamma X C Y gamma. Okay, this one. Either you can take this one or either you can take this one. So this is the, I will zoom it, this one, gamma X C Y gamma. Okay, oh, gamma X C Y gamma. Okay, that I have mentioned here. Now print it and make it 100 and let's see how much time it will take to simulate this one. Now it will save as like this one. So go into job, save it, run it, it will come here. Now this one, start it and wait for it to provide some results. Sometime structure will take longer to simulate because of number of atoms. If you have more number of atoms, that means it will take, maybe it can take 1 day or 2 days to simulate this structure. Okay, up to that we'll see. Okay, now the result is there, but I don't think so. Oh, it has C1. Yeah, it has C1. See, zigzag graphene nanoribbon.sdf. This is the band structure. Now for that one, you will see a metallic structure. Okay, metallic band gap. But okay, so this is giving a dual nature, so we have to increase. So you can see the zigzag structure is still showing a band gap because of the different width. I will show you it here. This one, measure tool. So it's having a very high band gap. Means higher the band gap means what? It required this much of energy to transport the electrons from valence band to conduction band. But this is very huge energy is required, right? So it is going toward the metallic nature, right? So this is the thing that you have to work here. Now I will show you some tutorials that will be helpful for you. See, in its main website, that is Quantumwise ATK, you can click on this one and you can see the tutorials. Okay, so in that one I will show you something. Semiconductor, PN diode. So So we'll see how to design the PN diode. Okay. So you all know P type and N type material, right? So this is a silicon PN junction. Okay. So if okay, do you know what is the difference between this silicon PN junction diode and indium gallium arsenide PN junction diode? Kunal, this is made of silicon, the PN junction. Okay, the P type and N type material. And now if we have indium gallium arsenide instead of silicon, what it will do? Any idea?
First of all, we will take silicon as semiconductor material. Then to form P-type or N-type means material, then we have to dope the material according to it to get P-type and N-type materials.
No, P and N type is just a density
Yes.
of your doping. Okay, I'm asking about this thing. This silicon PN junction is nothing but a simple diode that you are observing in the hardware lab. Okay, but if I will replace this silicon with indium gallium arsenide, can you tell me what kind of element you have in your lab for that particular combination? Have you seen LED? Hmm?
Yes, sir.
LED. What is that?
Mm.
Hmm? What is LED? LED is simply the same PN diode only, but having a different material property. And why it is emitting the light? Because of the property of the material. Okay, it's generating the photons. Yeah, that's why we are having a visual effect in that diode. That is also a diode kind of thing. Okay,
Yes, sir. Light
right,
emitting
Kunal?
diode.
If we are placing indium gallium arsenide in place of silicon, it will act as a light emitting diode. Okay, so can you access this one in your system? Can you access it? Please open this
Yes.
link.
Yes, sir.
Okay, and you can explore these things. We are having a different kind of tutorials for this one. Like if you go into this semiconductor, na, you will see a bunch of examples are there. Okay, to understand this one in more detail. So if you go with this silicon PN junction, you have to create this structure, but you cannot create right now because the PN junction diode, this structure is having a huge number of atoms. You can, if I will show you here, one second. See, this is a bunch of atoms here. Okay, so these number of atoms required a lot of time to compute this structure. Okay, if I will design this structure, you will get the result tomorrow. Okay, so we will only design a small structure, right? So the next one, I will show you one more presentation here. This one. Okay, now I will show you some application for where it is. So you should first understand what kind of things you can design in this one. Can you see it here?
Yes, sir.
So these are the application area that you can design by using this Quantumwise ATK tool. You can see that this graphene device means you are having a graphene device means GNR pad. Okay, in that one you can see this one is the metal pad and this one is the metal pad. In that both the metal pad you are having a graphene sheet. Clear? And this graphene sheet is combination of two things. You can see that one graphene sheet is up to here, second graphene sheet is here, and this graphene sheet has been tilted with some particular angle to join these things. Okay, this structure functional CNT carbon nanotube, that also you can design with the help of this software. Okay, this is the multi-wall, means one circular cylindrical is inside and one cylindrical is outside. I will show you these things how you can design this one. Okay, now apart from that, if you are having a two complex structure, and in between that if you want to put some impurities, so how to add those things? Silicon nanowire, hope you have heard about this one, silicon nanowire. So this is the center one is the silicon nanowire and these two are the electrodes. Okay, so basically you can design nanowire nanotube devices. Now I will show you how to design these things. So first delete this one. I'm designing on the same project. So suppose nanotube you want. So once you click the nanotube, it will ask you the bond distance. Bond distance means two carbon atoms, the bonding between the two carbon atoms, length of two carbon atoms. Okay, so here you can either have only one uh, centrally centered, you can say nanotube, one cylindrical nanotube, or if you want a multiple nanotubes you can enable the others one also. So if I will take only one thing with 6 number of atoms, it will show you like this one. This is, see here. Okay, this is just a preview. Now this is for inner tube. Okay, now if I will enable this one also, it will show you two things. Okay, two tubes, one is inner one and one is outer. Okay, so it is, now if I will enable this one, it will create one more at this point at the last outer side. Preview, see here. Can you see it?
Yes, sir.
Now I want to build this one. Click on the build. Now it is created. Now if you want a cylindrical kind of thing, you have to expand this axis, C axis. Okay, so I will go with this one and expand it. Repeat, we'll go into the repeat and we'll repeat this one. 6, apply, and now you can see the length. Okay, can you see? This is called multi-wall carbon nanotube. And if you want to change the visualization of this one, you can change it. Select this one, select this whole, go for the graphics property. Okay, and you can change the color. Now in this one I think okay, graphics only, atom color. Now you can see it here, so that you can visualize it, which atoms is inside and outside. You can even go for this one also, and you can change the color. Now you can see. Okay, so we are having 3 wall. One is center, or you can say inner, yellow one is the center, and this gray one is your outer side. Okay, now what is the brilliant zone of this one? That also you can find out. Now here the passivation means the outer edge. You can see that the outer edge is open. All the atoms outer edge is open, you can say, and you can feed it with the hydrogen atom here by default. See, it is now fed with the hydrogen atom. Okay, that also you can do, or you can also remove it. Here, now one more thing we can do with this option. You can see what coordinate is good to visualize. Suppose I want to see this coordinate, x coordinate. So you can directly click on this one. It will show you x coordinate, minus x, this one, minus y, z, and z. So this visualization you can do, or either if you want to change the rotation of this one manually, you can do it here from here. So this is the option, camera option, that will be helpful for changing the direction of this one. Okay, now this is my structure and I want to create a device. So this is basically a bulk. So how to convert this bulk into the device? So you have to go into the option device tool. This is my device tool. So click on the device tool and device from bulk. Click on the device from the bulk because this is right now bulk. So click device from the bulk, and now it will ask you the electrode, right electrode and left electrode. What is the length of electrode you want? That also depend on you. So the length of electron you can vary from here. Okay, these are the length of the electrode, but make sure that the length of the electrode should not be greater than the channel length. Okay, so it should be lower, and left one is lower. So now you can see that this one is the channel region, this one is the channel region, and this one is the electrode. This uh, straight light. Yeah, so you can see that this dotted line is your extended electrode, and this uh, straight line, you can say it is your main electrode. Okay, so combination of these two is your complete left and right electrode. Okay, so you can play with the camera here also. So once you click OK, it will convert this, yeah, it will convert your bulk structure into the device. Now you can measure the distance between the electrode and in the channel region with this scale. So this is my electrode, this is my channel region, and this is again electrode. So you can see that the channel region is more compared to your electrode. Okay, clear? So this thing you have to always maintain. Then only the electron will propagate from the electrode, one electrode to another electrode. Now once the device is formed, you have to give the electrode value, okay, that you can define here in the script generator. So now you can see here it is now converted into device. So now it, instead of showing the bulk, it is now showing the device here. Now for this device you have to always go for either for the semi-empirical or force field, because Lakau calculator and plane wave calculator will not work for this one. So click on the device semi-empirical calculator. Now it is a device semi-empirical. Once you click device semi-empirical here, it will ask you the voltage level of the electrode, right electrode and left electrode. Suppose I have put it 0.7. Okay, and now this one is also 0.7 volt. Okay, that value you can vary, right? And the remaining parameter you can put it as a by default. Click OK, and now what analysis you want for this device. Suppose I want VI characteristics, so search the analysis, what kind of analysis you want. So VI characteristics, mobility, that are the things you can identify here. See here, IV curve, double click IV curve. Okay, and mobility of this structure, hope this will count. Yeah, mobility won't be done on this calculator, so Hamiltonian will be counted. Okay, but this is not required for current, only IV characteristics. Spin, stress, total energy, eigenspectrum. Yeah, this eigenspectrum will tell you the value of the eigenvalue, or that you can say the transmission of signal through this channel region. Okay, once it is done, you can change the IV value, means biasing voltage, how much biasing you want to give in your device based on your research. Okay, and then you can give the sampling value, density value, and you can put OK. Same transmission spectrum. In that transmission spectrum, you can don't put it automatically cover bias range. You have to give the value at what particular range you want your transmission value, from -2 to 2 or from -1 to 1, that you can give. Okay, apart from that, you can choose this value and you can put the density value. Always put the density value. Okay, because it will enhance the computation value. And then okay, after putting all these things, you have to go for the job manager and you have to give, find out the results. Okay, but it will take a lot of time. So just run it and it will give you the result. Meanwhile, you can design different structure. Okay, so this is how you have to design the structure, right? So bulk design is done, and device conversion is also done from the bulk, right? And once you will have some hands-on on this tool, you will grab the things more uh, faster manner. Okay, now if you want to create a defect, you can create a defect in individual layers. Suppose I want to create a defect here, I want to delete this atom, simply click that particular atom and delete it. Now you can see that defect is there. Okay, and you can put the doping also. See here, suppose I want to put the doping in that particular area, this particular area. So select the particular area and click on the doping and add. Okay, and you can put the value here, whether you want N type doping or P type doping, that also you can do. In the PN diode, silicon based PN diode, you can put the doping here. You can even change the value of this doping. Suppose N type doping I want with a different value of 20, that also you can change and you can add it. Okay, now this doping is added here, right? Now I want to add some other doping P type here, that also you can do here, right? So this is the way to add some doping in the atoms. Clear? So today what you will do? Okay, one more thing I want to tell you. Suppose this is your device structure. Okay, now you want to convert this again into the bulk. So how to do that? Here you can see the split option. Okay, split a device into electrode, center region and electrode. That means once you click this option, the three part means left electrode, center electrode and right electrode, this will be splitted. You can see, and this is splitted structure will be shown in this tab. You can see it here. Click and you can see it individually. This is your left electrode. Okay, this is your right electrode, and this is your center one. So you can do that also. Okay. Yeah. Now you have to perform this PN diode using this tutorial. Okay, you can go through with this tutorial. Simple PN diode, just do this simple PN diode. Okay, they have also given a file, means inbuilt file also is there. See, you can see it here. This is inbuilt file also there. Okay, but you go with all the steps one by one. Okay, these steps I already shown you, the silicon, the calculation of band structure, that we already done. Okay, so after this, after this band structure we already seen. Okay, direct band gap and indirect. Now after that you have to follow this one. Okay, from here you have to go and design the PN diode. Clear, Maya and Kunal?
Yes, sir.
Okay, this silicon device you have to create with the help of this silicon alpha. Okay, so you create, you know how to create this along the C axis, just repeat it. Okay.
Yes, sir.
And this electrode value, that also you can, I already explained how to change the electrode values. Okay, and then the numerical calculation you can do, and you can find out the IV characteristics. Okay, this thing and density of state. Okay, now you have to perform these things. Okay, so you have access to that particular system.
Yes, sir. We are in the lab.
Okay, all three?
No, sir. Me and
Only
Neha.
two, you and Neha. Okay, so Kunal, how you will do? You take the access using any desk. Okay,
Yes.
only two system is having Quantumwise. So one can be taken by you, Kunal, and
Yes.
one Neha and Maya. You
Yes,
both
sir.
have to do one by one. Okay.
Yes, sir.
So you know which system we are having Quantumwise
No, sir.
on. Okay. Have you seen? I have put it some text. Do not use this, simulation is running system.
Yes, sir. But exactly, I don't know
Okay, I will
the number.
show. I will show. I am coming. Okay.
Yes, sir.
Okay.